Okay. So it must be up to about 4. So a drink of water. So let's think about another example. Consider the compound interest equation, which is f equals p 1 plus r to the n. And so what we've got here is we've got future value, we've got present value, we've got interest rate per period, we've got number. Maybe you're not familiar with that, with the hash. Let's go with number of periods. Okay, so this is an equation, and we've got 4 variables in this equation, and basically they could all be anything. But what if we were to say, well, actually, theoretically they could all be everything, but in the example that we're considering, 3 of them have values, and those values are p equals, what does p equal? P equals $1,000, present value, so I've currently got $1,000, which is great. R equals 0.005, so that's 0.5%, and n equals 12. So that's a number of periods, and a period could be a year or a month. It's just, it's as long as they're the same, the units of the period, so years, months, days, is the same as the units for which we're talking about the interest rate over. So we can put these values into our equation, but what is f? We don't have an f, so f equals, we don't know. So f stays as f, and we've got $1,000. We've got times that by 1 plus 0.005, and we've got 12 periods. And so we find that f equals $1,061.68. So that's all that is. That's all that substitution of numbers for pronumerals is. We just take an equation, we say, well, we know what some of the values of the pronumerals, we know what some of the values of the variables are, and so we can put those values in, and as long as there's only one pronumeral, only one variable for which we don't know the value, we can find out the value of that one. What? Touch on, touch off. Okay, next thing, solving equations. I'm just going to keep going because, I meant to stop at 15 minutes so I could upload it to YouTube, but I have to cut it out. I can just manually cut it. Okay. So, solving equations. 0.5, a very messy 5, but a 5 nonetheless. Let's pick our color. Okay. 5. So let's consider an example. An equation something along the lines of 4 minus 2t equals 3t minus 16. So we want to solve this equation. What does that mean? It means we want to find the value of t. First thing to think about is we want to get all the t's on one side. So get all t's on one side. And we could do lots of things first. We could try to move these t's over to that side, or try to move these t's over to that side, or whatever. But we're going to deal with this 16. So first thing we're going to do is add 16 to both sides. And so if I write this out longhand, we've got 4 minus 2t plus 16 equals 3t minus 16 plus 16. So this is the plus 16 from both sides, right? I got a bit messy, but that's okay. So what we notice here is we've got negative 16 and plus 16, and along our number lines we went 1, 2, 3, 4, 5, 6, 7, 8, 16, and then we came back, and we just end up at 0. So they cancel and go to 0. I can do that like this. They go to 0. And this 4 plus 16 gives us 20. So it simplifies to 20 minus 16 minus, just going to cross out, 20 minus 2t equals 3t. Okay, similar process with this one, except now we're going to deal with the t's. So what we're going to do is add 2t to both sides. Move down a bit, and we end up with 20 equals, I won't write it out longhand this time, 3t plus 2t. Well, I didn't write the t's on that side, and so we've got 20 equals 5t. So that's great. Now we've got all the t's on one side, all the numbers on the other side. We've got our apples in one bag and our oranges in the other bag. But now we want t by itself. If our t's are our oranges, and we've got 5 of them, but we want one of them, right? So what we have to do is we have to take 1/5 of all the ones that we have. So you can think of taking 1/5 by dividing it up into 5 pieces. 1, 2, 3, 4, 5. 5 pieces. So we've divided our bag of oranges up into 5 pieces, or we've multiplied it by 1/5. And so what I'm saying here is, in doing that, what we're doing is we're saying 20 divided by 5 equals 5t divided by 5. And these 5s are going to cancel. So what we have in the end is 20 divided by 5 is 4 equals t. So that was a pretty long-winded way of solving that equation. But, you know, in terms of solving equations, that's us looking at it. Just give that a moment. Another way to think about this is, you know, we've got multiplication, and the inverse, or the opposite, or the undoer of a multiplication is a division. So we just divide by 5, and then we get the t by itself. And if we had t over 5, we would just multiply by 5, and then we'd get, again, the cancelling happening, and the t by itself. And it's you can think about your bag of oranges, and you want to take 1/5 of it, so that you just have one orange, and you can compare that to the units on the other side. Next thing, writing algebraic expressions. Okay. Number 6. Writing algebraic expressions. So let's consider an example. So Ollie gets paid 5 chocolates for every 5 vegan chocolates for every summary he does, and 2 extra chocs for every minute of summary. Right? So the question is, how do we turn this sentence into an algebraic expression, or how do we express it mathematically? So there's a couple of steps that we can kind of take here, or a couple of things that we can particularly think about. The first thing we want to think about, first step, is identify the unknown. And I probably need to put a unknown in there. So I could say if he does a 20-minute summary, how many chocks does he get? Okay, I've made it pretty obvious. That's our unknown. How many? So our unknown is chocks. Identify, first step, identify the unknown. Chocks. Second thing we can do here is choose pronumerals. For all the variables. So let's find our variables. Well, one thing we've got is chocolates, and the other variable we have, Ollie. Is he a variable? Well, not really, because there's one of him, and we're talking about it acting on him for every summary he does. So summaries could be a variable. And 2 extra chocks for every minute of summary. But we notice that in this case, there's always one summary, but the way we kind of counting the summary is in minutes. So chocks is one variable, and we'll call that C. I could use a colon for that. And then the other variable is minutes, which we can call M. So we identify the unknown, which was chocks. Now we've chosen pronumerals for the variables. And now, the last thing we've got to do is look for keywords. Now when we're constructing the equation, we know that the unknown is going to go by itself on one side of the equation, right? Our unknown is chocks is C, and so C is going to sit by itself. It's the unknown, it's the thing we want to find out. And so in the same way that we were talking about solving this equation, and the thing we wanted to do was to get the T by itself, we kind of think about it the opposite way here. We're constructing an equation to find C in this case. So we start off with C by itself. So we've got the C there. And now we've got to look for keywords. So pick another color. He gets paid 5 chocolates for every summary he does. So for every summary. So we start off no matter what. Well, I won't write that because it's unnecessary and it's a bit confusing. But he gets 5 chocks no matter what for every summary he does. So the amount of chocolates he's going to get equals at least 5. At least 5 vegan chocolates for every summary. And then 2 extra chocolates. So this is us looking for keywords. 2 extra chocolates for every minute. For every minute of summary. Okay, so we had 5 to start off with, plus 2 extra chocks for every minute. So we can think about this kind of in a table form, where if we've got minutes and chocks, 0 minutes, how many chocolates do I get? Well, it's not really a summary, so it doesn't make that much sense, but let's just say it is a summary that goes for 0 minutes. I get 5. What about if it goes for 1 minute? Well, I get 5 chocolates, and then I've got 1 minute, and I get 2 chocolates for every extra minute. So 5 plus 2, 7, right? And then 2 minutes, 5 plus 4 is 9. So that's expressing starting off with 5, getting 2 for every extra minute. And, what do you know? We've actually just constructed a algebraic expression. So that was writing algebraic expressions. And all we did was identify the unknown, chocolates, and we knew that that goes on by itself. We chose a pronumeral for all the variables, so chocolates and minutes. It was kind of tricky to find that out, but I guess we knew it was minutes because minutes is the thing that something changes with. So for every minute, we get 2 extra chocolates. So minutes changes with chocolates, or chocolates changes with minutes, should I say. So we identified minutes. And then, so identified the unknown, chose the pronumerals, and then we looked for keywords. It's going to take a little practice, but those steps should hopefully help you sort that out. Okay, now the final thing, transposition. Number 7.